Okay, so let me skim through the, so this is usually my style of teaching programming. So there will be a lot of slides, and usually there will be certain slides that contains a lot of code. These are like Python codes. So when I explain the code, it's best if you not try to copy it while I'm explaining the code, just watch, right? And if the code is simple enough, I would say, okay, we don't have to actually try it out because it's so simple to understand. If some certain part of the code I think is important for you to try out and see the result on the screen, and also then I will leave time so that we can all type in the code or, copy and paste the code in together so you can see it in the screen. Certain kind of code where you copy and paste, where you do it on your computer, you can even change the input parameter and see the different effects. So it's kind of nice to see that kind of hands-on experience. Okay, so that's why it's important to have the slides on your computer, because in case that you are falling behind, you can just copy and paste. It's more important to understand the code and play around with it rather than just blindly copy without understanding. So that's why I'm totally even okay with copy and paste if you're falling behind, for example. But that's why it's important to have the code. Now, most of the code that we will be doing are on the slides. Not just this week, but all of the weeks. There will be some time. If you ask me a specific questions, then I have to improvise the answer and do a live implementation. Okay, those kind of codes will not be on the slide, but those kind of codes will be saved and then put on a Google Drive folder at the end of the day, so you can access it as well. Okay. All right, so today, so every day the lecture starts at 9:45 and it will end at official time is 12:15, but sometimes we end at 12 if we finish early. Okay, so today we have 26 slides. Let's see if we can make it through until 12. Because after today I have to run to the train station to go to Darmstadt for AU, so we don't want to go overboard for sure. Okay, so let's fire up your Rhino and Grasshopper. Okay, so one thing that I forgot to include in this first lecture is a list of books that can be helpful to you, like a reading list. I will try to add it next week, so sorry about that. Now, when it comes to so first, why we need to learn scripting in general or programming? Well, even if you use Grasshopper, which is basically allow you to do certain things that is impossible just to do with just mouse and keyboard, right? When it comes to modeling, visual programming like Grasshopper is not as expressive as textual programming. There's certain kind of logic that visual programming cannot express, or in case. Or sometimes if you supercharge or overload it or upgrade the visual programming languages with certain plugins, then it can become more expressive and you can do fancy stuff like even recursion or loop. But by the time you achieve that kind of logic, your visual programming script will look so messy and complex compared to writing the same logic in textual programming. Now, a good example is agent-based programming. Those are the kind of logic that is pretty much impossible or extremely messy or tedious if you just implement those kind of agent-based logic using visual programming alone. Especially agent-based, multiple agent-based, where you have a lot of, let's say that if you want to program a lot of robots moving around, where the robot has to continuously check for the nearby robots and try not to collide with them. Those kind of logic is nearly impossible or impractical to implement using just direct visual programming visual programming technique. So yeah, the point of learning programming is that you can achieve much more than just visual programming. And now we are doing so in the context of a master level education, like a master degree in computational design, digital fabrication. You have to know at least some basic scripting in order to proceed with the course. So in the context within the platform Rhino and Grasshopper, when it comes to actual write programming code, there are more than one choice of programming languages. Now, traditionally, you have VB script, which not so many, Rhino script, which not so many people use these days, because these days there's many more modern, more friendly languages. So you also have C#, but C# is only in Rhino, C# can be used to write a plugin for Rhino, but not for scripting. So it's not really a scripting language. In Grasshopper, C# can be used as scripting languages. And then came along Python, which is the most popular programming language on the world these days. Since last year, JavaScript has always been like the king of popularity, but since last year, for the first time, Python has become the most widely used languages in the world. Like scientists use it, like NASA use it. The people who discover the quantum, the gravity wave and won a Nobel Prize like 2 years ago and use Python. So scientists use Python. AI researchers use Python. So Python is a general purpose language. It's fairly easy to learn. It's not very suitable to write a big program with Python, but for like script, for simple algorithm, like for a small size algorithm, it's very suitable. So when Python was introduced to Rhino and Grasshopper, it became kind of very widely adopted, and probably is the most widely used programming language in Rhino and Grasshopper now. So there's two modes of using Python in Rhino and Grasshopper. Okay, the first mode is for Rhino, and the second mode is for Grasshopper. Now we're gonna spend probably 10 minutes with the Python programming in Rhino, but then we will switch to Grasshopper. The reason is that you will end up programming with Python in Grasshopper most of the time, because most of the workflow that you will be developed, not just for this seminar, but also for other seminars like digital fabrications, even probably for form instructor, if you end up using programming for form instructor and or the course, for example, most of the code that you write will happen inside Grasshopper, not in Rhino. Okay, but we will start with the Rhino Python code editor. So for those of you who have never programmed before, it's kind of useful to follow along. So I'm using Rhino 6 here. If you use Rhino 5, it's totally fine. So in order to fire up the Python code editor in Rhino, you have to type in this line called edit Python script. Okay, that's a command that will open the Python code editor. All right, and let's start with a simple program. So when you learn program, the classic thing is to have the so-called hello world program, where you write a little program that do a very simple thing, just display a text message, say hello world. So in Python, it's very simple. You have a special command called print, okay? And then after print, you give it a parameter, which is the text that you want to actually print on the screen. And let's say hello world, okay? It's a text, so that's why you have to enclose it in a pair of quotation marks. All right, so this is a simple Python program. Of course, our realistic program will be much more complicated than this, but this is the fully functional program. Okay, in order to execute, this is just the code, right? If you want to execute this program, you press the play button here, okay? It's called start debugging, but you know, it's still got a play button. So if you do that, this code will execute it, and at the bottom, you should see a message being displayed called hello world, okay? So within the code editor, this region is called the code editor region. This is where you actually type the code. This is the output panel that outputs just text content, okay? Now, if you generate geometry, then the geometry will either just live in the internal memory of the Python program that we're going to write, or you can output the geometry and you can see it on the screen, okay? You can also have existing geometry on the screen being read into the script so that you can edit and manipulate it using code, okay? All right, so this one is basically just documentation of the commands, the Python commands that is related to the Rhino geometry library. Now, this is a big library. We're gonna visit gradually some of the most useful commands, right? Okay, so that is the first program. Now let's start with a simple, let's have a slightly more sophisticated program. So now let's create a so-called variable, and we call it A, and we assign a value to it, which is 2. Okay, so in programming, a variable is just an abstract concept to store a value. Now here I have a variable, I declare it, and I store a value inside it, which is just the number 2. Okay, and in the next slide, I just display the contents of the variable A. Okay, now if I do this, if I run the script, you will see that number 2 being displayed. Okay. All right, and okay, we can have another variable. Let's call B, and we give it a different contents, which is also a number 4. All right. If you run this program, you will see the output is being number 2 because we only display A but not B. Okay, so when we create a parameter, it's live inside the program, but if you don't have a way to show it either as an output using the print command or as a geometric output, you won't see the result. Okay, and not everything needs to be displayed. Usually you only want to display the final result, right, but not the intermediate calculation. Okay, let's have something slightly more complicated. So if you have another variable, and this time we give it the result of 2 plus 4. Okay, so obviously the variable C will be 6. Okay, and if you print out the contents of the value C, of the variable C, okay, you will see the number 6. Okay. All right. We can reuse the variable. So for example, if you have a variable A that store number 2 and B that store number 4, you can say C equal to the value stored in A plus the value stored in B. Okay. And this will give you also 6. Okay. So everything so far is, I think fairly intuitive. This is no different from high school math that you are doing, really. But you can have other type of data as well. So far we have variables. Okay, we call it A, B, and C, and we store a number in it. But we can also have variable that store a different kind of data, which is not number. We can have variable that store text, right? So we can have a variable that's called my message. Okay, that's the name of the variable. So the name of the variable can be as long as you want, and then equal to, and we give it a value. Let's say hello iTech, for example. Now, if you run this program, you will not see anything being displayed because my message is just an internal variable or piece of data live inside your program. Okay, if you want to see it as an output, you have to print my message. Okay. Okay, and now if you run the program, you should see the word hello iText. Okay. All right, important distinction. So my message is a variable name. Here I say print my message, and the program knows that my message is a variable, so it actually extracts the value stored in that variable, okay, and display the value. Okay, it doesn't display the text my message because my message is actually not a text. My message is the name of the variable. Okay, so that's important distinction. If I do something like this, okay, in this case it will print out the text my message. Okay, but if I don't have the quotation mark, then Python will interpret this as a variable. All right, so just a quick try. If I put a, okay, this is my message. All right. Okay, so far so good. Now about naming convention. This is important. I will keep repeating this point throughout the course actually. So when you name a variable by convention, you use so-called mixed casing or camel casing, which means that the first letter is always lowercase. But whenever you have a new English word or new word, you start with the uppercase. So from now on, I want you to adopt a convention so that, you know, when I read your code for grading, for example, I can understand easily, okay? Also, there will be more guidelines and conventions about naming that you will learn later on as well, okay? But the first thing is about the casing, the uppercase and the lowercase, okay? All right, there's also restriction about naming. So of course, you cannot have space between the space within the name of a variable, because if you have space, then, you know, the programming language, which is Python in this case, will not be able to tell that these two items here are the same thing. You know, the space is used to separate stuff. So if you cannot have space in between, of course you can use the underscore, but normally you don't use underscore when name stuff in programming. There's certain case when you want to use underscore, but you should not use this convention at all, okay? All right. So we have done this example. You can have as many print message as you want, right? So without just to avoid giving you the illusion that you can only display something at the end of the program, you can have the print message which way. So for example, this is a program of 6 lines, A, B, and C, and then I print out the value of C here. Okay, so when the code execute, it will execute line by line. It will do this line first, and then this line, and then this line, and then it will display the content of C. Okay, and then it will carry on to the next line and display the content of my message. So if I run this program, I should see 2 outputs, which is number 6, which is the value of C, and my message. Okay, now everything happens so quickly. You press a play button and you see 2 outputs being displayed immediately. That's because this is a ridiculously simple program. Your computer runs so fast. But it's important to know that every program that you write will be executed in a certain order. Okay, this one is simple program, so the order will just be like line by line, top down. Okay, so everything that happened in a certain line will depends on what happens in the previous line. Okay, so for example here, the reason why I can say print C here is because in the previous line, C has been defined and fully kind of C has fully come into existence of the programming environment. That is why when you say print C, the Python engine is happily print out number 6 for you. Okay, but let's say that I have print C happen before this line. Now it's not hard to guess that if I run this program, I will have an error message that basically complains that I don't know what you mean by C. Okay, so because remember the program only executes from top to bottom. So if I run this program, I will see an error message. It will say the name C is not defined. Okay, it even tell you that this problem happened at line number 4. Okay. So, okay, I guess this is not difficult to understand why the error happens. All right. So, within today, most of the program, or all the program that we write within today will execute from top to bottom. But, you know, over the next day, you will see that the program that we write will be not necessarily being executed in a linear way. Sometimes it can go back to an earlier point. That is where things get more complicated and more fun. Okay. So all right, the next example that I want to do. So we have a lot of things going on here already. A, B, C, and then we have 4 variables. Now the next concept I want to show you is the this is the first time we declare and define the variable my message, right? And then you print out my message. Now let's carry on. So within the same program, we have the next command, which is basically we change the value of an existing variable to something else. Let's say that welcome to Stuttgart. Okay. And now if we print out my message we will get a different contents. Okay, so once you declare a variable and put a value into it, the value can still be changed. Okay, if you run this program, you should say hello iTech and then welcome to Stuttgart. Okay. All right, so now it's important to explain the concept of like what a variable truly is. So far we haven't output any geometry yet. We just deal with number and text, right? Just hold on for a moment. We will get into geometry eventually. You're going to see at least some points on the screen. Variables. I've been using the word variable, but how do you think about variable in a correct way? So of course, we know the term variable from high school math when you say x equal to 3, but in programming, a variable had some significant difference from the variable that you write on a piece of paper when you do math at school. So when I say a variable a equal to 2 in any programming languages, not just Python, what happens is that when this line is executed, this is a program we have a is equal to 2, so we declare a variable a, we put a number 2 inside the variable, and then we display the content of the variable. We say number 2 in the output. Now, but what happened behind the scene, which is I think very important to kind of have this mental image, is that the variable is like a container or a thing that stores actual value or data. So when you say a equal to 2 and then you press the play button, what happened inside your computer is that the Python engine will create a little box, which is basically just a little piece in your memory, in your RAM memory on your computer. Now that box or that piece of memory has a name A. Okay, so that's the name of variable or the name of the container. But this is a container that stores something, right? And that something in this case is number 2. Okay. So it's important to distinguish between a variable and the content stored inside a variable. They're not the same thing, right? When we do math at school, when we say x equal to 2, we kind of assume that, okay, x and number 2 is the same thing. But in variable, those are quite two separate things. Like one is a variable, one is just a container, one is the value stored inside it. Okay? And then let's imagine you have another line called b equal to 3.2. Then when this line is being executed, then what happened inside your computer is that there is another variable, another box coming into existence into your memory. Now that memory is called b, and then the content stored inside is 3.2. Okay. Now and then we display the content of b. Okay, so this one just take the content inside b and then display. Okay, so that's nothing surprising there. Now here's the important thing. Now if you accept the mental image that a is like a container and 2 is something that's stored inside a container, and a is actually not the content, a is just the label or the name of the container, then if you look at the next slide, we change the value of a to hello. What happened is that Python will not create a new container called a because a already exists, right? It actually go into the memory and say, I already have a box called a or a container called a. I just change the content into hello, which means that after this line, the number 2 will be lost forever. There's no point. There's no way after this line that you can query what is the original value of a anymore, unless you have other technique or mechanism to remember it somehow. Okay, but this point number 2 is lost. Okay. So of course now if you print out the program, the value of a, you will get the text hello. All right. So here you have container that store just text or number. Later on you will see that this container will store geometry data like a point or a vector or as complex as a nerve surface, or it can be like a mesh of like millions of vertices. Okay. Or you have a variable that store the data that describe a robot and all of the functionality of the robots. Okay, in that case, data is like big and it's gonna take up like a lot of space in your memory, for example. But here it's just simple. Okay, but this is the basic concept that we need to know. All right. And if you accept this image of the container and a value, then hopefully you will not ask me this question. Can I do, so instead of doing a equal to 2, can I do 2 equal to a? Now this is not a valid. So in mathematics, a equal to 2 and 2 is equal to a is the same thing, right? But in programming, there's no such thing as 2 equal to a, because when we say a equal to 2, this is not an equal in mathematics sense. It's just, this is mean that we have a container, and the equal sign is an action where we take a value and put it in. We doesn't make it equal in the sense of mathematics. Equal here, it means that it is the action of assigning or taking a value and put it in. That is why when you say 2 equal to a, it doesn't make sense. It's not like you are creating a variable that name 2 and put the letter a in it. Okay, this is not a valid thing. Also, one thing that I forgot to say about a variable name. A variable name cannot start with a number. So you cannot name a variable called 2018 group, for example. This will not work. Okay. Most programming language will not allow you to have a variable name start with number. Okay. All right. Alright, so far we have deal with variable, value, and now the next thing that's important to talk is called the types of the data, or data types. Okay, so this is the same program that we had. So the first line, a is the variable, 2 is the actual data, but the type of the data is an integer. Okay, so the actual number, the actual value of the data is number 2, but the type is an integer, or an integer number. Okay. In the case of a decimal number, then we call it a float. Okay. Well, maybe it's not obvious why a decimal is called float in programming language, but okay. From now on, whenever you see the word float, you immediately interpret it as a decimal number. Okay. And then if you have a data that is a piece of text, then the data type for that is called a string. Again, it's not obvious why we call text string rather than just text, but yeah, it's in programming, in most programming languages, it's called string. Okay, so whenever you see data type called string, you know that it contains a piece of text. Okay. And then the next data type we haven't done yet, but this one is very simple. So it's a data type that has only 2 values represented by the 2 keywords true or false. So this type is called a Boolean. Okay, so the full name is Boolean, but in Python it is shortened to bool. Okay, so true or false is keyword that represent the special value. So that's why when you type in the code editor will display this value as blue. Okay, and it starts with an uppercase. Okay, so if you do it as a lowercase, it won't be recognized as the special value true. Okay. Also because it's a keyword, so print is a keyword, true is keyword. That's why they are blue. And keywords mean that they are reserved word, which means that you should not name a variable using this keyword. For example, if you have a variable called true, of course Python will be confused, and it will have no way of like knowing whether you're talking about a variable name or a Boolean value. Okay, so you should not use those keywords to name your variable. Okay, so these are the 3 basic data types that come with the Python programming languages. Okay, four data types. And many other programming languages will support this basic data type, text and numbers and Boolean value. Now, later you will see, by the internet, you will see all the data types defined by the Rhino common programming library, and those data types can represent a point or a vector or a mesh object, okay, or something more abstract than just a geometry. It can represent, let's say, a Rhino file, or a layer in your Rhino file, or a color or a material. Okay. So 3 important concepts that we've learned so far that sounds the same but not. The first is a variable and its name. Okay. The second concept is the data that's stored inside the variable, and the third concept is the type of the data. Okay, they are not the same thing. Okay, they are related. So a variable always contains a value, and that value must always belong to a specific specific data type, but they are not the same thing. They always go like hand in hand, but they are not the same thing. And this is important because later on when you see the library, the documentation of random common, or when you get an error message, understand the data type, the data, and the variable will help you understand the error, right? Okay, so these are some of the extra data types that we will see later on in the course and today as well. Okay, this one I've already explained the difference between a variable name and text. So if the print command is kind of a helpful command that display a value or a message so that we know what's going on in program, right? If we say A within the quotation mark, then Python will interpret this as a piece of text and print out a letter A. But if A is a variable, and if you say print A, then you will get number 2. Okay, so that is just important distinction between a letter A and the text A. And also this is so I will clear this program and start a new program from scratch. If I have A equal to number 2, okay, and B equal to the text where the content is number 2. Now these are two different, totally different pieces of data. When you print out A and B, you will get identical display. The displayed result is the same, but they are different. First is the actual number 2, an integer 2. The second is just a piece of text that just happened to look like number 2. Okay, so they are two different variables, two different names. The data is different, and the data type is different. One is an integer, an integer number, and the second is a text. All right. So another example. So when you add 2 plus 3, and then you print out A, you get 5, right? Because this addition will add 2 numbers together. Okay, so you get number 5. Nothing surprising. But if you add text, okay, when you do the plus symbol over text, then the plus will not do an actual mathematical addition because it doesn't make sense. It will just join the two texts together, so you will get the text 2, 3. Okay, so if I print out, I will get the text 2, 3. Okay, so the takeaway message here is the type of the data really matters a lot. Okay, it will decide how certain symbol or commands behave. Okay, I'm not sure if you can do like this. So of course, intuitively, it doesn't make sense. You cannot add a number to a piece of text. It doesn't even make sense, right? But let's see if right now we do something. Yeah, so it complains here. Unsupported, so it means that the plus operator or the plus symbol in Python, it cannot add a string and an integer together. All right, so the data type does matter. Okay. So the error message never say that I cannot add the text 2 together with number 3. It just say the data type name. Okay, so that's why being aware of the data type is important in case you get an error message like this, and you can understand what's going on. All right. Okay, we have done this example where we use a variable before we define it. In this case, we print out A, but like A has not been defined previously, so you get an error message. Okay. All right, arithmetic operator. So you saw how we do the add operator. Of course, you can do divisions and multiplications. Multiplication in programming language is always the star symbol, and division is always the / symbol. Okay, so this one is easy. Okay, commenting the code. So when you have a long piece of code, or when you have something that's not clear to understand, it's useful to put in a few lines of comment or annotation or documentation, so that you or your friend, when they read the code, or when you read the code like a month later, you knows what is going on in your code. So if you prefix a line with the hashtag symbol, that line will become a command, which means that Python will not treat this as a code. So Python will not try to execute or understand what this means. Okay, this is just for human to understand, but not for the actual Python engine to understand. The code editor will automatically highlight the command, will automatically color the command with the green color. So I can make a little comment here. For example, I can say my first program, okay, and then semicolon, okay. If I forget the hashtag, then it will not be green, and if I run this, obviously, I will get an error message. It will say that my, it would say first is like an unexpected token, or like it's an unexpected item, okay. But if you have the hashtag, then the program will run fine. This line will just be completely ignored when the program runs. Okay. Okay, logical operator. So we have the math operator like plus and minus and division and multiplication. This one is logical operator. So if you have a variable called A that store the value true and B store the value false, you can do operator like A or B. Okay, so in this case, A is true and B is false. So true or false will give you the final value of true, and that final value true will be stored in C. Okay, same with AND. So true and false. So true and false will give you the final answer of false, and the final answer, which is a piece of data that has the value false, that one will be stored in the variable D. Okay, and not will basically just reverse the thing. Okay, now you will see the moment why logical operator is useful, but before we do that, let's look at another type of operator called comparison operator, where you can compare not every data types can be compared, right? If you have number, you can compare them. So A equal to 3 and B equal to 2, okay, that part is easy to understand, and C equal to whether A is greater than B. Okay, so if you look at from left to right, it's some of you might be confused and not sure which one will be executed first, but actually this part here will be executed first. So A greater than B will be performed, and then Python will realize that yeah, A is indeed greater than B, and it will evaluate that to a value true, and this value true here I just put in a command to mark that it's true, but it's not a real code, right? So this true will store in C. Okay, so C, if you print out C after this line, you will get true. Okay, I can also print out directly without storing it in a variable. So print out the result of whether A is greater than 4. Okay, and this line will print out the message. I lost it somewhere. Okay, let's try this. Okay, A equals to, what did I have here? 3, B equal to 2. Okay, I ask whether A is greater than B, and I store the result in a variable C, and if I print out C, I will get the value true. So if I run this code, I should see the value true. Okay, so that is the case where, so remember, this is the value, this is an expression that will be evaluated to a certain value, and then you store that value into the variable, and here we display the contents or the value stored inside the variable. You can also display a value directly without storing it in the variable. So for example, without this line, I can just say A is greater than B. Okay, so this whole thing, it will, when it's being executed, it will be evaluated to a value. In this case, will be evaluated to the value true, and then true will be displayed right here. So if I run this one, I will get true. Okay, so not always you need to store a value in a variable. Okay, if you have a value, you can pass it in a certain command. But here we haven't learned much command. We only learned about the print command, so that's why we can send it to the print command right away. Okay. Okay, so we can do and, so print a greater than b, okay, and b is greater than 1. Okay, so this thing is clearly true, this thing is clearly true, so the whole thing is true. Okay, so I should get a message true twice. So this one will give me a true, this one will give me a true, so I will see two value truths being displayed. Okay, the last line, this one ignore it. This one is actually an incorrect line of code. Okay, what if I want to evaluate this expression a and b, which I know will have a value true, right? And okay, I'm doing something silly here. Hello world. Let's see if Python will run this one. Yes, print out hello world. Let me see. Okay, this is annoying. I should expect an error message here, but Python tried to do something clever here. What I was trying to say is that data type doesn't matter. So this is a Boolean value and this is a text value. It actually doesn't make sense for you to AND a Boolean value with a text value, right? So I should expect an error message here. But Python somehow convert this to a text and then join the two texts together. But anyway, please ignore that. Certain programming language try to do data conversion behind the scene. And different languages, they have different rules. So okay, we've done that. So these are all of the simple examples that we've done in isolation. We're not like using it in a real exercise or a real use case yet. Okay, conditional statements. Okay, so far all of the program that we've done is only execute line by line from top to bottom. But here's the first time you see a case where certain line will be skipped. Okay, certain line will not be executed at all. Okay, so here a simple program again. We have like variable a and b with the data 3 and 2, and they are integers obviously. And then now we have a special statement called an if statement. So if is the keyword, that's why it will be displayed blue in your code editor. Follow if. Following the if statement is an expression that can be evaluated to either true or false. So a greater than b is an expression that can be evaluated to true or false, right? And then we have the colon. Okay, and then in the next line of code we have this thing called print a is larger than b, and there's an indentation here. Okay, so what does it mean is that when this line of code execute, Python will try to evaluate this to see if it's true or false. If this is indeed true, it will execute this line of code. If this is false, then this line of code will not be executed. Okay. In this case, of course we can know in advance that a is indeed greater than b, so you will see the message being printed out on the output panel. So let me copy this. I'm missing. Okay, I see a message saying a is larger than b. Okay, so nothing surprising here. If I change the value of a and b to intentionally make this thing false, okay, now if I run the program this time, nothing will happen because this condition is not satisfied. So this line of code here was not executed at all. Okay, so two things to take away. the line of code that following the if statement has to be indented, and you normally use the tab to make the indentations. If you use Rhino 6, I think the indentations can be either the special indentation symbol or just for space. But if you use Rhino 5, I think it has to be a space indentations. Okay. So here I have only one line of code, but don't think of this is just one line of code. Here can be a mini program. So here can be as many lines of code as possible. These are a mini program that will be executed whenever this condition is satisfied. So let's make this thing more complex. And let's say C equal to A plus B, and then I print out the value of C. Okay, so this is a slightly more complex program. It has 3 lines. And look at the indentation. The indentation tells Python that these 3 lines are within the same block of code that belongs under the if statement. Okay, and these block of code is only executed when this condition is satisfied. So if I change the condition again, okay, 6 free, okay, then I will see the first print message and then the second print message, which is number 9 here. Okay, now to show you the effect without, okay, if I make this false, okay, now clearly if I change the value so that this condition is false, then I will not seeing anything. Now just to demonstrate the effect of indentation, so Python used the indentation to know that these block of code belong to the if statement. If I don't indent this line, then essentially these 2 lines will be separated from if statement, which means that Python will go in here, check the if statement, execute, decide whether to execute this one, and then the if statement will finish. It will go on to the next line and execute this one independently of the if statement. Okay, so even though the condition is true, this part is still being executed. So if I run this, I still see number 9 being output here. Okay. Now normally when you write a program, in order to make the program easier to read, you insert an empty line between an if block and whichever following. Okay. So this is just for readability, this empty line. Okay. Okay. So let me check if the recording is still running. Okay, good. What time is it now? 11. Another version of the if statement is where we can attach an additional part called the else part, which will be executed when the condition is not true. Okay, so this is a classic. So if something is true, then you execute the program underneath it. But sometimes it's useful to specify the else situation. So the else part will be executed in the opposite case, right? Okay, so in this case, we'll print out a message: A is not larger than B. Okay. So I will copy it in. So in this case, I should get, with number 3 and 2 here, I should get A is larger than B. Okay, if I change the value, okay, I should get A is not larger than B. Okay. Now again, indentation does matter, right? So everything that belongs to the else bit will have to be indented relative to the indentation level of else. Okay, and this can have as many lines as you want. This is like a mini program in here. In this example, you have only 1 line for the if part and else part, but it can be as complex as you want. Okay, all right, nested conditional statement. So as I say, the program here can be as complex as you want. In fact, you can have another if statement execute within the body of another if statement. Okay, and you will see here in a second. So this is a sample when we are given three number and then we have to output a message that tells us which one is the largest, right? So as we change the value here and we run the script again, we should get a different result. So find the largest number among A, B, and C. So we use the if statement. We say if A is greater than B, okay? And then we're gonna write a little piece of program here that do further calculation. And now and then in the else part we will have a body here. Now in the case if A is greater than B, then we ask ourselves the next question: if A is greater than C as well, okay? In that case, A is clearly the largest number. Now look at the indentation level. This whole program is part of the if statement. That's why everything is indented relative to the first if, right? This part belongs to the second if. That's why it's relative. That's why it's indented one level relative to the second if and two level relative to the first if. Okay. And then else. So if A is greater than B and A is greater than C, then A is the largest. But if A is not larger than C, then clearly C is the largest. Okay. So else. So this else go with this if here, and this entire block. You see, this is the mini program itself that is part of the if. Okay. All right. In the else part, the logic is similar. So when you do the else part, clearly B is greater than A. Okay. And then you keep asking if B is also greater than C, then clearly B is the largest. Else C is larger. So we have two mini programs which are themselves if and else statement within an if and else statement. And of course, you can like nest it as many levels as you want, right? You will see like kind of nested conditional logic quite often in programming, so don't be surprised. Okay, so that is the Python bit in Rhino. So now let's switch to. Do you guys need a 10-minute break, or shall we carry on, or you want a 10-minute break? Huh? I think we are relatively fine. We have not that many slides. Okay, we can have a 10 minutes break until 11:20. Okay, enough for you to grab a coffee downstairs. Okay. Okay, just okay. Those of you who are not in the iTech email list, you can add your information here, and I will send you the invitation to the Google Drive at the end of the day. Yes. You have to contact Katja. She's the one in charge of buying it. Usually we do it only once a year, so it's out of season now. I'm not in charge of buying it. You can use a trial version, which lasts for 90 days. That's enough for this course. Yeah, if you can download one with 6 brand new, you can use them up to 9 for 90 days.
Okay, copy it from above.
It's kind of useful to follow along. Otherwise, you can do it at home. You can rewatch the video and follow along. But yeah, without following, it's learning programming is like learning by doing.
It's just, I think his computer is again, like it's not control, it's something else.
Oh,
Like
it
the
might be in
keyboard
a
is
different
different, that's why I wasn't able
language.
to type.
I think it's copied and pasted.
Ah,
I think it's already copied.
okay. Where's the controller? No. Okay.
Do you know how to do it? Karen, thank you. Like 10 times. I'm just so confused. It's like a really small course or something. Yeah.
Fuck.
Can you tell me how to do the edge? Because
ads?
yeah, this one.
Okay.
Because I only have.
Oh, no, I don't know.
This one, and cool. Ah, okay.
You live there. I didn't know you were after me. Oh, I didn't know it. Yeah. This person.
That's what is the underscore? Is this? ينفع. It's not that? Yes. Yes. Nice.
There are a few more tables. I'm not sure if we can borrow.
Oh yeah. Oh, right. I just couldn't find like the days where very
I will give you I will put on a recommendation. There's a recommendation book for you. But there's no book that teach you directly teach you programming Python with Rhino Common Library. So
You're really stupid.
you just copy and paste from the previous one. Okay, you the last one, I guess.
Yeah.
All right. Okay, invitation to Google Drive have been sent to all of you who have just given me an email. Let's save this before I forget. Okay. Okay, let's carry on. So we have done Python in Rhino. Now from now on we will use Python almost exclusively in Grasshopper. Okay, so let's fire up Grasshopper. Oh, yes, duplicated. Okay, video recording still running. Good. Okay, now we're gonna create a Python script component. So the script component, the Python component, is in the Math tab, and it's right here. Or you can search for Python. So double left click and search Python. Okay. All right. This component will inside it will contain a piece of Python program or script that we will author, that we will edit, and whenever there's an input change or whenever you press refresh button, that Python script will run, and basically that will be the functionality of this guy. So currently this guy doesn't do anything because the Python script inside is empty. So if you give it input, it will do nothing. There will be nothing output. It's just like a useless Grasshopper component. Now, in order to open the code editor that is associated with this particular component, you double click on it and you will see a code editor. If you use Rhino 5, the content inside the code editing area will be completely empty. If you use Rhino 6, there will be like some pre-existing code, but you can safely delete all of these. Okay.
Are you recording?
Yeah, it's recording. All right. Okay, let me check. Okay, microphone. All right. Okay, so this is where we write our program, and this is similar to what we had before. So if I say print hello world, you don't have to follow this step. This one is just very easy, so don't have to follow hello world. If I run this program, if I press the test button, all of the print command, the output will be in this display panel here. So you see hello world downside here. Now, of course, in a realistic Python script, we want to actually in a realistic scenario, we want to actually output some useful data right here at the output port so that you can use it further downstream, right, in Grasshopper. The thing that we output here is just like for helping us understand what is going on in the code. In the case there's an error, we can use the print message to print out the intermediate result of a long program. But this program currently is still useless. It doesn't do anything useful, obviously. All right, I can have, so you see this code editor is associated with this Python component, and like there's like a visual hint here to tell you that this is belong to the association between the code editor and the Python component. I can have another Python component, for example. Again, you don't have to follow this step. If I open this one, I have another code editor, and this will be two separate Python program. Okay, but of course now we work with only one. So. Alright, so the Python script here will take in some input, do something internally, and most of the time it will output something useful. It can be geometry output here, or it can be a piece of text, okay? And not every time you want to output something. For example, if you want to read in 10 circles and just extract the XYZ coordinate of the circles and save the coordinate in a text file so that you can import the text file into another software, that is the case where you don't output anything. You just like make a physical file on the C drive, but you don't on your computer drive, but you don't output anything onto the Grasshopper canvas. Okay. All right. Before we write a program, we need to look at the input. So here there are two inputs into this component for you to use, and one output port being declared by default. This output port that is labeled out. This is a special output port. You should not mess up with it. I will show you. I will tell you why it is there. Okay. In order to change the number of input and output, right? Usually Grasshopper component come with a fixed number of input and output because they have been fully predefined, but a Python component is like an empty where we will use Python to define the functionality. That is why we can decide how many input and outputs we have. And if you zoom in close enough, you will have the chance to add or remove input and output, but please don't press the minus here, don't remove the output here, okay? This one is important, just leave it there. So I can have another input or output and change the name. So if I right click, I can change the name of the input, okay? But just leave them at X and Y for now, okay? And I will just use 2 input for now. All right, so the input name, the grasshopper input name will also happen to be the name of the Python variable that we will be using inside the script here, okay? So whichever value that we plug into the X input port, and then we refer to the X inside the script, then X will like has that value that we input in, okay? So let me show you. So if I have a panel, okay, and then I just put in the word hello iTech, okay, which is just a piece of data of type string, right? If I put it in X, okay, now I open the code editor. Now at this point, if I print X, now previously in the random code editor, if you say print X, you get an error message that says that X has not been defined. But in this case, X just happened to be the name of the input port, which means that it's already been defined via the input port, okay? So it's not defined explicitly within the Python program, but it's defined within the Grasshopper user interface. In this case, if you print X, you should see the message hello iTech this appear here. So hello iTech, okay? All right. Now, what I tell you about, remember before the break, we talked about variable, the data stored inside the variable, and the type of that data, okay? So working with programming, the type of data is very important, right? A circle is different from a curve, right? So you can have many curves, but the type is curve and not... You can have a curve where the shapes look like a circle. When you draw it on the screen, you can mistake it as a circle, but if you look at the data type, the type is a curve, not a circle. So data types are actually very important, and sometimes it's happened behind the scene, so you don't actively know, but it's always like there. So keeping awareness of it is important. So in this case, we have 2 inputs. So now we are, as an exercise, we're going to make a Python script that take in 2 numbers, computes the average of the 2 numbers, and then output it here. Okay, so very simple program. So the input we call this X and Y, and then what else? Now the name of the variable is going to be X and Y. The value will come from other components, right? Next thing is the data type. Okay, so we declare. So we right click on X and choose the type hint, and we're gonna read this in as a decimal number. And again, in Python, decimal number is called float. So we're gonna choose float here. All right, and then we're gonna choose the same thing for the input Y, type in. Okay, so that's for the input. For the output, we don't declare the data type because the data type will be decided by the Python script internally, right? So now I have 2 numbers. I just make a small panel here. I put in number 2.0 or just 2, and then another number, maybe 3.14, the pi number. Plug it in, plug it in. Of course, this day nothing happened yet. We have the input, but the program is empty inside, so there's no functionality yet. All right, let's open the code editor. Okay, and then we will say X plus Y. Okay, we need to start in a variable. Okay, we can start in a variable called, say, my result, but this example is simple. We actually just want to take the value of the expression X plus Y and send it to the output A right away. In that case, we will just say A equals 2. Okay, so A is a variable, but it happens to be the output port at the same time. Okay, so it's both a Python variable but also the name of the output port. And in this case, if a Python variable has the same name as the output port, then the value of that variable will also be sent out to the output port. Okay, so if I press OK, and if I have another panel here just to display the result, I should see 5.0 14 here. All right. Okay, so nothing surprising here. Everything is as intuitive as expect. Now the nice thing about writing Python is that Grasshopper is that it's work with the parametric graph, right? Which means that if you change the input, okay, if you change the input to something else, the Python script inside will be re-executed automatically, and then you get a different result. Okay, so if you have a slider, as you slide the slider through, the same script will be executed many times. Okay. If you do the same thing in the Rhino editor rather than the Grasshopper code editor, whenever you change the input, you have to press the play button again. Okay, but here it's fully parametric, so it's much nicer to work with. Now, what about this output port? So this one is a special output port that reserved to display everything that you send to the print command. So if you print something else, it will be displayed down here, and in addition, the content of this thing will also be sent to the output port. Okay, so if I have another thing here, okay, another panel here, and if I print out the message, I just print out the value of hello world again. Okay, then I will see hello world appear here and also at the output port. Okay. So this thing is mostly for debugging. So, in case you don't know what I mean by debugging, bug is just an error in the program. Bug as in the insect, right? But in computer programming, bugs means an error, and debug means you just try to eliminate the error. So a large part of a programmer life, of a programmer is like typically spent on debugging. So a large part of your programming time will spend on like fixing the error or debugging. So the print command is usually, and the output port is there for debugging purpose, where you can print out a certain. So if you have imagine you have a really long program of 100 lines, and you want to print out the value of A here, so that you can check that okay, A is correct as I expected before the next part of the program executed. Okay, and here you can have like more further lines. It's super complicated, for example. And by print out a value of A, you can monitor, and then it can help you understand and debug the program better. Okay. All right. So we have two floats coming in and one number coming out. One float coming out. Next, let me close this one. Okay, now enough with numbers and text. Let's do some real geometry. So far we haven't touched anything on the Rhino Common programming library yet. Okay. Oh, that's just one more step. We try to compute the average number of x and y, right? So let's make it correct. So instead of a equal to x plus y, we have to say x plus y divided by 2, right? So bracket divided by 2 or multiplied by 0.5. They are the same thing. Okay. So now I have the average of two numbers, right? So that's the first simple exercise. Okay, so from now on, whenever we do an exercise that involving a Python component, I will usually have a screenshot here, and then this little box, because by looking at the screenshot, you cannot really tell whether this thing is a float or not, because it's in the right-click menu, right? So I have to like write the information here. So whenever you see the screenshot and if you follow along, then you know that you have to prepare a Python component on your own computer, and then set the input and the output according to this name. Okay, so this is the preparation step before we actually type in the code. All right, the code in this one is simple. All right. So on the slides, I actually store the value of the math here in a temporary variable average, and then I send the average onto the output port. Okay, so this is what I showed on the slide, but like in what I just did here, I skip over the middle step, so I don't have the temporary variable. I just send the numerical value to the output port directly, which is fine. Okay, now using Rhino command. So Rhino command is the name of the programming library. It was written in C# originally, but Python, or at least the version of Python that we're using, is compatible with C#, which means that everything that was written or originally written or programmed in C# can be accessed using the Python programming languages. Python programming language. Okay, so let's have a very simple example when we take in 3 numbers and when we're gonna create a point, a 3D point, based on those 3 numbers, the XYZ coordinates, and then we're gonna output that point. Okay, and you should see this point appear on the screen, right? So when you have a component that creates geometry, the geometry will be displayed on the screen. I mean, that's how Grasshopper works, right? So let's create this component, okay, XYZ, and set them to float. Okay, right. Actually, I will just reuse this one. Add in another one called Z, change the type hint to float. Okay, I will go in and delete all of the code because this is a brand new code, so delete all of the code. Alright, so now we're going to write the code to generate the point or to create a point. Here's what it looks like. Now the command, well, it's actually called a function or a method, but because we haven't learned what is a function or method, so I use the word command. Okay, so the command that actually create the point, that command is defined in the Rhino command library. Okay, now so far we haven't dealt with any Rhino command library commands yet, but now this is the first time we dealt with it. So that's why at the very first line at the beginning of our code, we need to import that library. Okay, so we say import, which is a keyword, then the name of the library, which is rhino.geometry. Again, you don't have to type it in right away. It's just like what and I explain, and then you have time to type it in or copy and paste. Okay, so this is the name of the library. This library is actually physically defined in a file stored on your C drive, in like C program files, Rhino 6 or whatever. It's a physical file where Rhino is installed, right? That file is already visible to the code editor. So that's why we don't have to manually point Grasshopper to that physical file on the C drive. We already see that file on the folder. Here we just like call out a name from that file, which is rhino.geometry. So this is the name of the library, one of the library inside Rhino command, and this is a rather long name, so that's why we give it a nickname, or as the terminology go, an alias name. So import this library as RG, which means that from this point onward, whenever I use the word RG, it means that I refer to this library. Okay, if I don't do the sRG, it's still fine, except that you have to refer to rhino.geometry using the full long name here. Okay, so this just shorten the name so that in the following lines I can just like use the word the short name RG. So import rhino.geometry as RG. Okay, now I'm gonna create a point. So this slide has many things to explain. So here I create a variable. So this slide should be familiar. So my point. Again, the naming convention, lowercase, but whenever you have a new word, you start with uppercase. So my point equal to, so this point is just an empty variable. Now on the right hand side of the equal sign, now this is the command that gives us the data of the point. Okay, so the command is called point3d uppercase. Okay, the command lives inside the library rg, so that's why we have to say rg first and then dot point3d. Okay, so whenever you refer to any command or functionality within the library, you have to say rg and then dot and then call out the commands. And then this is a command. So We haven't done any command so far, but this is the first time we have a command. Okay, we have a print command, but that is a special command, right? That's a special command that comes with the Python language. This is a standard command called pon3d. A command always, when you use a command, you always specify the data that the command needs inside a pair of brackets. Now this command needs 3 pieces of information, which are 3 numbers. So we open a bracket, throw in 3 numbers. The numbers are separated by the comma. Okay. Some command does not take any input at all. In that case, you still need to open the bracket, but the bracket is empty inside. Okay. Alright, so after this command finish, you will have a piece of data that represents a point, and we store that point inside this variable here. Okay. So if you run this code, what happens behind the scene is that, okay, remember the explanation I told you about before the break. A variable is like a container in memory. So yeah, at this point it will, when the code executes, it will create a little container inside the computer memory, and that part of memory is called my point. The data stored inside is a point that has the coordinate 1, 2, or 3. Okay, so this is the actual data, but this is the variable name. All right. So if you run this program, a point will be created and stored inside the internal memory of the computer, but you won't see anything being output to the grasshopper canvas. Yes. So we need to add one more line. A equal to my point. This one is like where we take the value stored inside my point and send it to the output port A. Okay. So let me try this with you. So I open this, and I will say import rhino.geometry as rg, and then I will create a point called my point equal to rg.point3d. and A equal to my point. If I press OK, and then I can see a point being displayed as coordinate 1, 2, and 3. And if I hover the mouse here at the port A, I will see that indeed there's a point coming out. You don't need to. Where? Or in my code? Yeah, it's my habit from C#. I'm a C# programmer mostly, so I have this habit, but it's not necessary.
Is there a reason why you code you cannot code directly with one A?
You totally can. You totally can in this case. Yeah. You can say A equal to this thing. Yeah, but I just want to demonstrate that you can have a temporary variable because it's a nice name. Yeah. I will tell you a bit of good workflow guideline later when you only do the output at the very last minute. So you always start the result in the temporary variable, do a lot of computation there, and only output at the last minute. That's why, okay, here we don't have any computation, so it seems redundant to have my point, right? But later on, especially when we hook a timer to this component to force run multiple times, that's it's very important that we only do the output at the last minute. Okay, all right. In the next step, so now we have created a point using a fixed value of 1, 2, and 3 for x, y, and z. In the next line, in the next step, rather than using 1 and 2 and 3, we use the value from the input x, y, and z. So let's replace 1, 2, and 3 here with the input variable x, y, and z. Okay. X, Y, Z. Okay. If I press OK, then okay, now it will use the value from the input. If I change the input, the point should update right away. Okay. Okay, so I guess nothing surprising so far. Okay, so at this point in the code, we have a variable that stores a piece of data. Now, what is the data type of this data? Well, the data type is called point3d. So, name of the data type in this case is identical to the command that we use to create the actual point. So, if you say my point, okay, so this is a variable of data type my point, of data type point3d. So if you have a piece of data that belongs to a certain data type, then we can do certain thing. For example, if you have a data type, if you have a data of type integer, then what you can do with it is, for example, add it with another integer, right? Or give it to a command that asks for an integer. Now, with my points, there are certain things that you can do, or certain property that you can query. If this is a point, if you say dot capital X, this will give you the X coordinate of the point that was just created. Okay, so for example, here, if you say print my points dot X, okay, it will print out X coordinate, and that X coordinate should match whichever we used to create at the original point. So if I run this one, I will have 5.0, okay? Now I will tell you in a moment why I know that a point3d has a .x property, okay? Alright, so here we have a command, here we have a property. They are separated by the dot, so the notation is the same, but the meaning is quite different. So x is actually a variable that stores the number 5.0. So here in this case, x is 5.0, right? So x is actually a variable, but when a variable belongs to another variable like this, we call it a property. So my point is a variable that represent a point3d, and that point3d has a property called x, but the value of x of the .x property has the value of 5.0 because that's how I set it, and the data type for that property in this case is a float. Okay, so just to demonstrate, you don't have to follow this step. If I have another variable called my number equal to 3, if I query my number .x. Now, in this case, I get an error message because my number is a float, right? A decimal number. A decimal number doesn't have any property called .x at all. So if you run this thing, you will say that yeah, a float object. So the word up. I cannot make this larger, but okay. So the error says float object has no attribute x. So okay, the word attribute and properties. The .x here, the word attribute and properties are kind of interchangeable in programming language, right? So I say attribute means it doesn't have any property, and also the word object and variable they're not the same thing, to be honest, but they are quite interchangeable. So this is a variable, but it's also, we call it an object called my number, right? The object 0.3. Oh, no, this is a variable, and the object is 0.3, and the object has type float. Okay, so I keep using the word data. So a variable store data, but actually in Python they don't call it data, they call it an object. So the object that happens to be a number, so the object has a data type integer. The actual value of the object is 0.3, and that object is stored in a variable called my number. Okay, so there must say that the object of type float or float object or decimal object doesn't have any property or any attribute called .x. Alright, so apart from .x, of course you can do .y and .z obviously, but let me show you where these properties come from. Okay, So if you know that the data type of your variable is pon3d, then this data type is defined in a Rhino common library, not a Python, not the standard Python library. So if you want to look up the documentation of the data type pon3d, you have to go online and Google for Rhino common documentation. There's also an offline version, but the online version is much more up to date. All right, this is what the documentation looks like. It's very scary at first, but hopefully you will be able to navigate it in the next few lectures. And not just this library. These days, almost any programming library, the documentation will look the same. So if you know how to navigate this thing, you will be able to navigate all the library as well. So for example, if you want to later do programming for 3ds Max or Maya or even AutoCAD or Revit, and each software comes with a programming library for user to make plugins or make external script. The documentation, of course, the content is different, but the way that the structure is very similar, and the terminology used is very similar because they are all based on object-oriented programming paradigm. So, okay. So we want to look for the data type. So these are the Rhino common library. Inside there are many so-called namespace. Okay, forget about what namespace meaning at the moment. Think of this as a folder. So Rhino common is a big library, has many data type, has many commands inside it. So that library has to be organized into a structure of folder and then subfolder within folder, and then the commands will actually be defined within the folder, right? So far we import Rhino geometry, Rhino.geometry, which is just one of the many folders in the entire Rhino common library. So Rhino geometry is here, and if you expand Rhino geometry, so this is the folder name, a subfolder name, and inside you have a bunch of data type. So this is a BREP data type, BREP class. So it's a BREP data type. We haven't know what is a class or a structure mean or enumeration. But let's go to Rhino to pon3d. So pon3d is here. So pon3d structure, again, we don't know what a structure here, but for now you can replace the word class and structure with the word data type. Okay, you know what the data type is already. So look at the pon3d data type. So if I click on that, or if I expand it, click on that, this is the documentation for pon3d. Okay, again, I know it's very scary at first. It will take some time to get used to. Now, this whole library is originally written in C#, so all of the example codes are in C#. But thankfully, since Rhino 6, the people at McNeil has slowly added in Python sample code as well. But I don't think they are complete yet. So there's many example where there's no Python version at all. Anyway, so how do I know that the data type pon3d or an object or a variable of type pon3d has the .x property? Because if I scroll down here, if I go to properties, it has an .x property, or the property called x, but when you access that, you have to say .x on the variable name, right? And then this is the explanations of the meaning of that property. Okay, in terms of .x, it's very obvious. You don't even need to look at the documentation to know what .x actually does, right? But not so many. There's many things that's not so obvious. So if you click on the .x, it will give you further information, and you can always backtrack at any time. Okay, you have .x and .y and .z. Okay, so for pon3d data type, those are the most important thing. Okay, good. So let's look at the next example. Okay, we just done that. We access the .x property. We take out its value and display it. Okay, so we have done that. Okay, in the next example, we're gonna read in 2.3D object as input, and then we're gonna compute the midpoint of A and B, and then we output it. Okay. So let's do a component. Okay, this one you can follow along. So Python. So let's prepare a component together. It's called A and B. Now the data type is pon3d. And the output is just called capital M. Okay. All right, and after that we open the code editor. So here I violate my own naming convention a little bit. So we know that this is also just not just the name of the input port, but also the name of the Python variable, right? And as I told you previously, by convention it should be lowercase a, but there are some exceptions I make. This is not universal exception, by the way. This is just my own exception. So when naming point, I usually uppercase, because in mathematics, when you name point, you usually use a capital letter. Okay. All right. So here's what the actual code look like. Okay, the first line, you import the Rhino.geometry .geometry subfolder inside the Rhino common library. All right, you know how to extract the x. So in order to compute the midpoint of 2 points, then you basically just compute the average of the x coordinate, average of the y and the z, right? And from those average value, you construct a new point, and that is the midpoint. Okay, so let's compute the average of the x coordinate of A and B. Well, you know how to query. So this thing coming as point 3D. Remember, we right click on it and we say that it's a point 3D, which means that when it comes to the Python script, it already has a data type point 3D, which means that if you say a.x, it will happily return you the x coordinate of A. Okay, so a.x, this thing will be a number, and then b.x will be a number. So we just add two numbers together and divide by 2 or multiply by 0.5. And so this whole mathematics thing is just a number. And then we start in a temporary variable called mid.x. Okay, so middle x. We do the same thing for y and z. Okay, so and from the value of middle x, y, and z, we can build a new point 3D object. And that will be the middle point that we want to output to the output port M. Okay, so we will say M, which is just a variable name. Okay, and now we have to give it the actual data. So we construct a new object or a new piece of data that represent the point 3D from scratch. So we say rg.point3d. This time the xyz coordinate will be the variable that we compute earlier. Okay. Right, so if we do this part only. Okay, so if you don't have any input, you will get an error message, obviously, because it will say that A is undefined, so we have to give it 2 points. The first point I just pick on the screen, plug it in here. The second point. Okay. And then M should be the point in the middle. And as you change the point, then the midpoint should also be updated automatically. All right. Okay, now in the next step, so that's the midpoint. Let's compute the distance between A and B as well, and then we're gonna print. We don't send that, so we compute the distance, but we don't send the result as an output parameter. We just like print it, so it will be sent into the output port here. that will be sufficient for this exercise. So if you know the XYZ coordinate of A and B, you can do a little math to compute the distance, right? Based on your high school math, I hope you remember how to do it. But fortunately, we don't have to do that math ourselves, because in the Rhino command library, there's already a command to compute the distance between 2 points, because that kind of thing is so common that the Rhino command library has already kind of provided a command to do that. Otherwise, we will have to write all of these mathematical formula that we learned from high school, which is not very tidy. Okay, so we're gonna invoke the command that compute the distance, and then we had a result and store it in the variable called distance. Okay, so on the left hand side, so let me expand this line. The left hand side is just a variable that we're gonna declare from scratch. It's called distance. And then on the second line is the command that actually runs and will give us the value so that we can store it in the variable called distance. Okay, so the commands belongs to the data type point3D. So A is a point3D, right? And if you look at the documentation, it has a command. So this is the first time you call a command that belongs to a data type. Okay, so if you look at point3D, it has inside the method sections. Okay, we haven't learned what a method is, so that's why I use the word command. So command and method and function are kind of interchangeable, at least for now. Okay, command is kind of easier to understand. When I say the English word command, it's kind of more intuitive. So a command is basically just an action. A variable is not an action; it just store data. And then command is an action, right? So one is a noun and one is the verb, essentially. Okay, so so we look at the command called .distance2 here. Okay, and if you click on that, this is the definition of the command distance2 written in C#. So okay, it's a bit cryptic to understand, but basically this is the name of the functions or the command. And because it's the command, whenever you use it, you have to open the bracket and then supply the input parameter. In this case, the input parameter is another point, is another object of type point3D, which is, in this case, we're going to choose the point B, right? So here, A is a point3D, it has a distance2, that's why I say .distance2. I open the bracket, and because it asks for another point, so okay, I give it another object of type point3D, which is B. So the command will be executed, and after it finishes execution, you will get a number, a float. Okay. Now, of course, in this case, we know that the result has to be a number, because what else can it be, right? But in some non-obvious case, you have to look at the documentation to tell you which is what is the type of the answer that it gives you. Okay. Again, the documentation is written in the C# language. In the C# language, they call it a double. So double is just a C# version of a float, which is just a number, right? So this is the function, this is the type, the value, and type, that data type of the data that will be returned, which is a number. All right. So .distance2, and then we just print out distance. Okay. So as you see in conventions, almost all of the commands, so variable name is lowercase, but command names is almost always uppercase by conventions, at least in the C# world. In the Python programming library, some of the commands are uppercase, are lowercase, like the print command, which is make it kind of inconsistent. But the random command library was defined, written in C#, so it has, and C# generally has a quite stricter naming convention. So all of the command name is uppercase. Okay. So if you do a .distance2, so distance, which is my variable name, and the value will be the result of this command. Okay, and then I just print out the value stored inside distance. Okay, and remember the value will be output here, so I will have a panel to monitor its value. All right, and as I change the input, you should see the distance change. Okay, carry on. Okay, so looking back at the code here, I compute the average XYZ coordinate by manually access the X and the Y value and then do the normal number addition and then multiplication. However, in the Rhino Common Library, you can add 2 points directly and get the total point. So you can replace these 4 lines here with one single line, which basically say m equal to 0.5 times a plus b. So remember, a and b are 0.3D data type, right? And fortunately for us, you can add 0.3D directly. So the result of a plus b is another point where the xyz coordinate is just the sum of a and b. Now, so we get another point, but of course we don't start in a variable yet. We multiply it with 0.5 right away. So when you multiply a number with a point, it basically you will get yet another point where the coordinate is just xyz multiplied by that's normal number, and then the whole thing will now be that new point, and then we start that new point in a variable called m. Okay, so this you can replace this 4 line with this one. So whenever you want to compute the midpoint, just much shorter. All right. So okay, I'm not going to try that out. I think it's fairly easy to understand. So just delete these 4 lines and replace those 4 lines with this line. It works. Okay, let me talk to you about other data type like vector 3D. So this is how you create a vector. If you output a vector onto the Grasshopper canvas, you will not see anything. So vector 3D will not be being displayed directly. You have to send the vector 3D into the vector display component if you want to visualize that vector on the screen. Okay, I don't think you need vector right away. So many of the thing is just intermediate steps. So if you look at the program that we wrote here, we have a variable here, but this is just a temporary variable to store a temporary result. Like this is not our final answer, so we don't even output it onto the screen. It just lives inside the Rhino script. So not every variable has to be output, okay? But sometimes in a long program where you have a lot of variable, and then in order to make sure that like this variable at a certain state has the correct value while you are trying to fix the error in your program, you can use the print command to print out the value just so that you can check that it has the correct value, okay? But not everything needs to be output. Okay, this is vector. Okay, so carry on to other data types. So vector 3D, for example, there's many cases where you create a vector, but you don't need to output it because the vector is just being used internally inside the program in order to build other kind of geometry object. That's how you create a vector from scratch. Okay, we have done point. You can create a plane object. A plane object, if you output it, you can see it being displayed on the Rhino viewport directly. Now so this is how you create a plane object. So rg.plane. So the data type is plane, and the command to create an object of the data type is the exact same name of the data type itself. Okay. Of course, the exception when we do number integer and string, we don't create new data using this command. When we say number 2, we just say a equal to 2, and then if the text, we just put the value in the quotation mark, right? Those are the basic data type. But beyond that, those basic data types, whenever you want to do like special data type that is defined by another library, like Rhino Common Library, whenever you want to create a new value from scratch, you always use the syntax, the library name, dot, and then the command that has this exact same name as the data type. And because the command, you have the pair bracket and the information that it needs to construct that piece of object or that piece of data from scratch. Okay, so the plane constructor or the plane construction command, if you look at the documentation, it has more than one version, but I'm using the version that taking 2 input. The first is upon 3D that specify the origin, and the second is a vector that specify the normal. Okay, so if you use this one, it will construct a plane at the specified origin with the specified normal vector. It will automatically chosen the x and the y axis for you. How do I know that it behaved that way? Because the documentation told me so. Okay, of course in this case it's intuitive that the point here is obviously has to be the origin, but in many cases it's not obvious like what the first input do. And that's the case that you need to look at the documentation. All right. Okay, I can try this out quickly. So we do a plan. Okay, and then I output the plan. So my output now is actually called, actually let's do it in a brand new component. Python. Okay, so the output now is called O plan. So O is O just mean output. It's just a naming convention that I make for myself. So O plan is equal to my plan. If you do this, you should get a plan coming out right here. Okay. Now the data for my plan is like fixed value that I hard code, or like I fix it in this thing, but you can use the input value X and Y for this thing if you want to, obviously. So that's the plan. Here is how you do a circle. So again, rg.circle, this is how you construct a new circle object from scratch. The circle construction command we take in a plan, an object of type plan as the first input. So that's to specify where the circle is. Again, the documentation told me so, that's why I knew. But these are common, so that's why I can't remember this command by heart. But you know, you have to look at the documentation. And then the second input to the construction command is a number. And okay, it's not hard to guess that this is the radius of the circle. But again, most of the case will not be as obvious as this. All right, and then I output the circle. Okay, if I try that, I should get a circle as well. New variable O circle. All right, get a circle lies on the same plane with radius 2.5 units. Yeah, it's 3 units actually. Okay. You can try the line command. So rg.line. Okay, so if you look at the documentation, rg.line will have many construction commands. Now, obviously, there should be one that take in 2 input, which is 2 point 3D, right? The first point 3D is start point, and then the other one is the end point. Okay. If you look at the documentation, there should be so, and hence that is your. Okay, so this is the last slide before we talk briefly about the simple assignment that you have to do for this week. So if you look at a command has many versions, and each version is different by what kind of input you throw into it. Okay, so look at these 3 different plan command. They are 3 different versions of the same command because they have the same name, which is plan. Okay, or actually, when you use it, you have to say rg plan, but the name is just plan. But when you use it, you have to say rg plan because the function plan is defined within the library rg. Now, these functions, this command. The first version take in a point 3D and a vector 3D, and will give you a plan around this origin, and the vector 3D will act as the normal vector. And then there is another version that take in an origin, which is a point 3D, and then 2 vector 3D, which is the x and the y. Okay, so these are the data type, not the actual data. Like when you use it, you actually have to give it a real point. Here, this is just like the label of the functions or label of the commands. But when you use it, you actually have to give it a real point. Okay. Same with circle. Circle has many versions. There's a circle that's taking a point 3D, which is the origin, and then give you, and then just a radius. Okay, this plan construction command, it will take in 3 number. That makes sense because from 3 number you can uniquely define a plan, right? So that's why writer commons give you this command as well. Okay, so now your job is to, I will make an assignment file here. I will save it on the, so you need access to the Google Drive. On the assignment, so the submission will go here. But the data you need, so this is week 1 assignment. Okay, not every week you will have an assignment. Like some assignment we spend over 2 weeks. Okay, but normally it will be weekly. So I will save a grasshopper file here. So this is just week 01 assignment. Okay, so I will specify the condition here. Scribble. Okay, so your job is to create a Python component. that takes in free input. You can call it anything you want. Free input of type .3d. Okay. All right. And then your job is to write a Python script that output the following thing. The component shall output three lines that connect the 3 points into a triangle. Okay, we haven't do the line commands, but now you should be able to look it up on the right corner command documentation. Okay, I show you how to do circle and plan. Okay, the line should be similar. Right? So should output 3 lines that connect the 3 input points. Okay, so you need free output for each line, right? Obviously, so you need to. We haven't done list output or list input yet. So if you have a list of free items, you have to output them as 3 separate output. Okay, so you have free output part, and then the midpoint, the middle point of the triangle. Okay, and then you know how to compute the distance between 2 points, and also you can compute the length of the line, right? If you have an object of data type line, it should have something dot get length, which is a command that return the length. Okay, right? So you can look up the documentation. So the next output gonna be the perimeter or the total length of the triangle. Okay. So I save the template here, and please copy it to your computer before. Don't overwrite it, otherwise your friends will. Actually, let me make a backup copy just in case. Okay, this one is called dot backup, but you have to change the. Okay, backup. All right, this should be fairly simple assignment based on everything you've learned so far. Should allow you, should enable you to do exercise. And there's more than one way. So for the last item, compute the perimeter of triangles. There are at least 2 different ways. You can query the length of the lines that you create in step 1 and add them up, or you can compute the distance between the points directly and disregard the lines. Okay, it's up to you. But you have to do it in Python, obviously. I'm sure you know how to do it in Grasshopper visual programming, but okay, now we just do it in Python and using Rhino Common. All right, the submission will go into the assignment submission. So I will create a submission folder for week 01. So inside the submission folder, each of you should create a subfolder with your family name, okay? And then inside that subfolder, you should put in the Grasshopper file. For this assignment, you only need to submit the Grasshopper file and nothing else. But in later, you might need to submit other additional data as well. Okay. So, all right. I will see you next week at 9:45. Make sure that you install Rhino and everything for next time. The video will be uploaded tonight. I have to go to the train station now, so I'm not sure if I have time to compress the video and upload, but. Okay, it should be on. I will try to make it within today in Darmstadt, hopefully. Okay, all right. Have a good lunch and enjoy the rest of your day. See you.